Welcome to our presentation about password strength checker using discrete structures, applying sets and logic by Hannah Lopez and Hector Gomez. What is discrete structures? A branch of mathematics dealing with discrete elements fundamental to computer science. Includes set theory logic and Boolean algebra graph theory functions and relations recursion and induction. Why is it important? Helps structure data models, the logical flow in programs essential for algorithms, databases, and cybersecurity backbone of computer programming languages and software systems. What are sets and logic? A set is a collection of distinct objects. Logic enables us to make decisions by applying conditions. Together, they are used to evaluate and solve real-world problems. Real-world example, password strength. Websites check if passwords include uppercase letters, lowercase letters, digits, symbols, and are long enough. These checks are logic-based and use character sets. This helps in ensuring user accounts are secure. Python program, password checker. The program checks password components, uppercase letters, lowercase letters, digits, special characters, minimum length, 8. Based on the score, it ranks the strength weak, moderate, very strong. Logic in action. Uses int function with logical conditions. Combines conditions using Boolean logic. Evaluates strength based on some conditions met.
As you can see right here, this is our coding example for our password checker. Take a second to review if you'd like. I'm still going to break it down in a second. Alright, so first we're going to import the string module. The string module gives us easy access to sets of characters like ASCII lowercase and ASCII uppercase and digits. Then we're going to define a function with the name isValidPassword. And we're going to set password as a parameter. And this will return true or false based on the rules. This is our Boolean example for discrete structures. In this set of code, we're defining sets of valid characters. In this case, we're doing it for the lowercase letters, uppercase letters, digits, and special characters. It compresses the code a lot and it makes it easier to check for membership and to make sure that our password complies with the rules that we are setting. In easier terms, all of the lowercase letters go to the variable lowercase. All of the uppercase letters go to the variable uppercase or the set uppercase. All of the digits go to the set digits, and all of the special characters that we put in the parentheses right there, all of them go to the special set. Alright, so now we're going to check our rules. What are our rules? We have to have at least one uppercase letter. In this case, we have has underscore upper. We got to check at least one lowercase letter, has underscore lower, and so on. We also have long underscore enough. That we have to check that the password is at least 8 characters or more, and not underscore common. That is not one of the common weak passwords. All the way in the bottom, I put any and in an example of code inside the parentheses of the any function. And this means that if any character matches the condition, it returns true. So the any function is a built-in Python function that, like I mentioned, returns true if any character matches the condition. However, we wouldn't be able to do this without the generator expression. And I believe that this is a replacement for a for loop or a mini for loop that checks each character in the password to see if it's uppercase. Instead of writing out a full for loop and a conditional statement, the generator expression does it all in one line. Then the any function looks at the results and returns true as soon as it finds an uppercase letter. Just like a for loop would break once it finds what it needs. And the same goes for has lower, has digit, and has special. Then we have long enough. Pretty simple. We check the length in password, our parameter, and then we check if it's greater or equal than 8. Then we lump all of these rules together. And then this is valid equal all, and then we have all of our rules in there. Returns true only if all rules are met. This function returns the final result, valid or invalid. So now we're going to put a user input. So we set a variable password is equal to the input. Enter your password. Once the user enters his desired password, we call the function isValidPassword with the user's input. And then we're going to print out a message depending on whether the result is true or false. In this case, we use a if statement, and then if isValidPassword is true, we print password is valid. Anything else, we put password is invalid. And this counts also for the common passwords. If we put in one of the common passwords that we put in our rules, like 1, 2, 3, 4, 5, 6, so on, or just password in lowercase, and the other examples we had before, it will return as invalid because it's not meeting all of the rules. So there you have it. We have 3 examples of how I use the code for checking for passwords. On my first example, we have a very, very, very strong password. No one would be able to guess it, of course, because it meets all of the rules. Then on our second example, very easy, very common, of course. We are setting these rules, of course, and we said that if it didn't meet the common password rule, we would exclude it, and it would be invalid. And on our third example, it's almost there. We're just missing a little bit. We're missing that extra security, but it's still invalid because we're not meeting one rule. So in our password code, our password checker code, we used password rules, which involve decision making, which is at the heart of Boolean logic. We're also checking character types, which uses sets to group and validate inputs. Writing the logic as a function follows the structure of discrete math functions. This is a real-world example of how math concepts apply to security software. We see it everywhere. We see it when we're making a new password, where it says it doesn't meet, it's not strong enough, or it doesn't meet all of our requirements. Every time we create an account, and I'll show some examples right now, every time we want to create an account or change a password, we're always met with these requirements, and it's kind of annoying because of course we would like to have these easy passwords that don't require us to be typing all around the keyboard and that have to be 14 characters long, but of course it's for a safety, and we all have to follow these rules. So I believe this is a great way to show how we use discrete structures in our everyday, because this is something that happens every day. This is something that we see every day, and it maybe went unnoticed with a lot of people, including me. I didn't know this was discrete structures until I did this example. So this is everything for our presentation. Me, Hector Gomez, and Hannah, thank you for your attention, and have a good day.